back to Maths with Mrs. J. I wanted to introduce to you the idea of the remainder theorem and its sort of little sister, the factor theorem. This is very useful when you're trying to factorise polynomials that have a degree higher than 2. In other words, things that are like not quadratic, they might be cubic or quartic or whatever. It can be very handy to be able to find a linear factor and divide through by that, and then it makes the whole process simpler. Let me just try to explain to you what we're talking about when we're talking about the remainder theorem and the factor theorem. I'll read this out and then I'll sort of interpret it in everyday English. The remainder theorem says that if a polynomial p of x is divided by x minus a, then the remainder will be given by p of a. Okay, well, what does that mean in everyday English? Say we have a polynomial, we'll call it p of x, and it could be anything. It could be, 3x squared minus 5x, no, actually, we'll make it a cubic. 3x cubed minus 5x squared plus 8x minus 1 or something like that. And say I wanted to know what's the remainder going to be if I divide by x minus 1. Now I could do the long division all the way through to the end and just see what the remainder is. Or I could use this rule and say, okay, this rule is telling me that if I'm going to divide this by x minus 1, all I need to do to work out what the remainder will be is to work out what p of 1 is. So we sub in p of 1, sorry, sub in 1 I should say, and what do we get? So we get 3 minus 5 plus 8 minus 1, which is what? 5, I believe. All right, so x minus 1 is not a factor. We can tell that straight out because there is a remainder and we know that the remainder would be 5. How would I be able to get the remainder if I was dividing by x plus 1, do you think? Because the rule says x minus a, the remainder is given by p of a. So what we've got to think about here is that x plus 1 is really x minus negative 1, isn't it? So the remainder in that case would be p of negative 1. I'm not going to do that now, but that's just to sort of give you a little tip of what to do there. Now, the special case of the remainder theorem is the factor theorem. It makes sense. We know that if we have a remainder of 0, that whatever we've divided by must be a factor. That's logical. That makes sense, doesn't it? So the factor theorem states that x minus a is a factor of polynomial p of x if and only if p of a is 0. First of all, let me just expose you to this expression, IFF. That is not a mistake in my spelling. It means if and only if, which means it works both ways. So if x minus a is a factor, then p of a will be 0. But similarly, if p of a is 0, then x minus a will be a factor. So it's a two-way street, all right? So that's a little bit of new shorthand today. You know that mathematicians don't like writing too much stuff, even though I've written a lot there. We have these little shorthand ways of saying things. So that means if and only if. So if this, then that, but if that, then this. All right, let's actually answer the question that we were asked to do. Is x plus 1 a factor of that? Okay, well, let's call it p of x. How would we know if it's a factor? Well, let's work out what p of negative 1 is. And if that comes out to 0, then we'll know that x plus 1 is a factor. So let's sub it in. So negative 1 cubed plus 3 times negative 1 squared minus 5 times negative 1 minus 7, which is what? Negative 1 plus 3 plus 5 minus 7, which is what? That's 0, isn't it? So, is it a factor? Yes. Yes, it is a factor. Now, just to do a little bit of extra practice of our division, I will just show you that I am actually correct and that the remainder does come out to be 0. You don't have to do that because we've already shown that it's a factor. That's what the factor theorem is saying. But just to do a little bit more practice of our long division, let's just do that division and see what we get. So if you have x cubed plus 3x squared minus 5x minus 7, and we're going to divide that by our x plus 1. Okay, leading term divided by leading term, x cubed divided by x is x squared. X squared times x is x cubed. X squared times 1 is 1x squared. Do your subtraction. Get 2x squared minus our 5x minus our 7. Leading term divided by leading term. Multiply back through. And then we subtract again, they will go. Negative 5x minus 2x minus 7x minus 7. Leading term divided by leading term. And then multiply through. And yes, indeed, we do get a remainder of 0. If we were asked to fully factorise this cubic expression, we'd have to then look at this quadratic part of it. And because the discriminant of that is not a perfect square, you're not going to be able to factorise that with rational numbers. But we'll leave that for another day. For now, the important thing to understand is if you want to know the remainder when dividing by x minus something, sub in that x value to the polynomial and whatever you get as your answer will be the remainder. If that remainder is 0, then you know that that must have been a factor.